Hello again, everyone. SpaceX's Raptor engine experienced an explosion during testing. While this may sound alarming, it's likely not a major problem. In fact, it could represent an important step forward in preparing for future moon missions. At the same time, SpaceX's Starbase continues to make significant progress, with upgrades and developments moving forward at a rapid pace. Meanwhile, in China, preparations appear to be underway for the launch of the Shenzhou 22 to the Tiangong space station. Let's explore all these developments in today's episode of Great SpaceX. When discussing SpaceX's Starship systems, it's natural to immediately think of Starbase, the bustling hub where assembly, testing, and launch operations converge. Starbase is the visible heart of the Starship program, showcasing the complexity, scale, and ambition of SpaceX's next-generation spaceflight systems. However, it's equally important to remember that at McGregor, Texas, engine-related activities are ongoing and critical to the success of every Starship mission. This is where the Raptor engines, the powerhouse of Starship, are tested, refined, and pushed to their limits before ever leaving the ground. Recently, a Raptor 3 engine exploded during testing at McGregor. While seeing an engine explode may sound alarming, in the context of SpaceX's development process, it's not necessarily unexpected. What makes this particular incident notable is that the explosion occurred during engine startup, rather than during a long-duration static fire, which had been the more common scenario in past incidents. Observing an engine fail at startup raises natural questions about whether the engine has a defect, perhaps related to a localized manufacturing issue or a modification in its design. Despite initial concerns, the probability that this indicates a systemic problem is low. Raptor engines have undergone extensive testing, and prior prototypes have shown impressive reliability. This suggests two plausible scenarios. Either this was an isolated issue with a single engine, or SpaceX intentionally conducted a high-stress test to evaluate the engine's limits. Considering SpaceX's history of deliberate stress testing to ensure mission readiness, the latter explanation is the most likely. Next year, the Raptor 3 engine will play a critical role in several high-stakes Starship missions. Flight 12, for example, will involve the first relighting of a Raptor 3 engine in space, a milestone crucial for the program. Following that, Starship missions will include deploying payloads into orbit, constructing a refueling system in space, and executing a complex two-stage landing sequence. Each of these missions depends on the engine's ability to reliably restart after being shut down. Past flights have occasionally struggled with engine reignition after extended operation, so confirming this capability under real-world conditions is essential. Independent engine testing at McGregor is particularly valuable because it allows engineers to push the engine to its operational limits under controlled conditions. By deliberately testing the startup sequence to failure, SpaceX gains critical insight into the engine's performance envelope. This approach helps identify potential weaknesses, allowing engineers to correct them well before they could compromise actual missions. The lack of an official statement from SpaceX regarding this recent test suggests that the company views it as a normal part of the development process rather than a cause for concern. The timing of these tests is also significant given SpaceX's lunar schedule. Leaked documents indicate that the uncrewed lunar landing demonstration is planned for June of 2027, with a crewed lunar landing following in September of 2028. Preparatory refueling missions in space are scheduled to begin as early as June of 2026. Leading up to these milestones, Flight 12 in January will focus on engine relighting, while additional missions in the first half of the year will involve payload deployment and two-stage landings. With such a tight timeline, early testing is crucial to ensure that the engines are fully capable before the high-stakes lunar missions. Refueling operations present a unique challenge because they must be performed repeatedly while preserving engine and vehicle reusability. This means that SpaceX will require a substantial number of engines and prototypes ready for testing and upgrades. Conducting rigorous engine tests now allows the team to anticipate issues and implement improvements, maximizing mission reliability while maintaining schedule flexibility. In summary, the recent Raptor 3 engine test at McGregor, despite the explosion, is a likely planned and essential step in preparing for the critical missions ahead. It demonstrates SpaceX's commitment to testing, risk mitigation, and readiness for the next generation of Starship operations. Supporting the SpaceX team during this intense period is important, and fans are encouraged to show their encouragement by responding "Keep going" in the comment section down below, and also like the video and subscribe to follow the ongoing journey of Starship and SpaceX's ambitious plans for space exploration. At the heart of all SpaceX operations is Starbase, where the most intense activity is taking place as the company enters a new era of Starship development, testing, and launches. Let's begin with the remnants of the old era, specifically OLM Pad 1. After Flight 11, this pad has been undergoing a thorough demolition process. Components such as the QD system, protective shields, clamps, and piping have been all gradually removed. Then on the 16th, an iconic moment occurred when the first leg of the OLM was officially knocked down. Witnessing this event brings to mind similar demolitions in the past, such as the Low Bay and High Bay, which were early symbols of the Starship program. While it may seem destructive, each demolition is in fact a necessary step that opens the door to a new era of innovation and capability. With OLM Pad 1 following the removal of the first leg, the remaining 5 legs will continue to be demolished. This process is expected to be completed within the week. After each leg is taken down, all debris will be cleared from the pad area. Once the entire old design is removed, SpaceX will begin excavation for the flame trench. After shaping the structural space, the team will pour concrete, install rebar frameworks, pour additional concrete, construct the flame bucket, build the OLM platform, install the BQD gantry frame, position the OLM, connect BQD systems, and finalize other smaller installations. Based on the current pace of work, the full Pad 1 upgrade is likely to be finished by the middle of next year, potentially entering service in the second half of the year. It's important to note that this timeline primarily affects the test and launch support systems. Another portion of Pad 1, known as Chopsticks, will become operational sooner to assist with the capture of both stages of Starship. This upgrade involves shortening the 2 arms and adjusting internal systems to match the Starship V3 configuration, a task that is expected to be completed relatively quickly. In contrast, Pad 2 represents the new era and is steadily reaching completion. The latest updates show the installation of the BQD methane hood, likely the final major piece of this system. Its installation indicates that the fuel lines have also been connected. During this process, Pad 2 has also been undergoing continuous testing with Chopsticks and the deluge system from the flame trench. What remains most anticipated is the first static fire test. Pad 2 may need to wait for booster B18 to complete cryogenic testing and engine installation before its debut, as booster B17, which was initially expected to support Pad 2 testing, is now being demolished. Speaking of B17, it's another example of older generation hardware being retired, making room for the next generation vehicles. The first ship V3 S39 is currently attracting the most attention. Over the past weekend, the final aft section of S39 was rolled to Mega Bay 2 and stacked with the rest of the ship, marking a significant milestone in the completion of the first Starship V3 production. Looking back, the stack of S39 began with the nose cone and payload section in October on the 13th. The total stacking process took just 33 to 34 days, which is faster than the previous record of 42 days for Starship V2. This increased efficiency demonstrates the inherent improvements of V3 even before any upgrades are proven in flight. With the lessons learned from S39, the production of subsequent ships is expected to accelerate further. This will be crucial as SpaceX requires multiple prototypes over the coming years to support key missions. S39 will soon move on to cryogenic testing, with the test stand recently relocated from the Massey test site to the production site in preparation. Overall, all current progress aligns with the timeline for Flight 12, scheduled to launch in January of next year. We are now on the verge of witnessing the official debut of Starship V3. The upgrades, speed, and new capabilities promise to be extraordinary, marking the start of a truly remarkable chapter in SpaceX's journey. Everyone watching should get ready to see just how transformative this new era will be. And now, let's turn to the latest update on China's crewed space missions. As we know, after the Shenzhou 20 crew returned safely using the Shenzhou 21 spacecraft, the Shenzhou 21 crew remains in a precarious position aboard the Tiangong space station. Their situation is particularly concerning because they are effectively stuck in orbit with a potentially damaged spacecraft. This creates a clear need for a follow-up mission to ensure the safety and well-being of the astronauts, a fundamental requirement for any crewed mission. Recent updates indicate that China is moving quickly to address this. According to the CNSA Watcher website, the Shenzhou 22 launch preparations have begun, with rocket testing underway and cargo being loaded for both the astronauts and the space station facilities. The report did not mention additional scientific payloads, suggesting that the priority is focused squarely on crew safety and station support. A link to the update was also shared on Weibo, one of China's major social networks, highlighting the transparency of the preparation process. All preparations are clearly aimed at minimizing the time the Shenzhou 21 crew must remain in a risky situation. However, the cited 10 to 20 days for prep is notable. Previous reports suggested that in an emergency, China could activate a rescue mission within approximately 8.5 days. Extending the preparation window to a maximum of 20 days understandably raises concern, as it prolongs the period the crew is exposed to potential risk. At the same time, the longer prep period is understandable given the circumstances. The Shenzhou 22 mission was originally scheduled with 6 months of preparation, but the unexpected situation forced the team to compress testing, installation, and verification timelines dramatically. This means the spacecraft and the rocket must be fully prepared for launch in a fraction of the usual time, which is a significant technical challenge. China is balancing two critical factors: speed and reliability. Accelerating the process reduces the time the crew is in danger, but ensuring the spacecraft functions perfectly is essential to avoid compounding the risk. No mission can afford to send astronauts aboard a spacecraft that has not been thoroughly verified. Both objectives must be achieved simultaneously to guarantee crew safety and mission success. As the Shenzhou 22 launch approaches, it'll be fascinating to see how China manages this sensitive period. The world is watching closely to see how the aerospace industry handles the pressures of emergency crewed missions while maintaining the highest standards of safety and reliability. This situation underscores the complexities and challenges inherent in human spaceflight, even for highly experienced space programs. Reborn from the ashes, SpaceX's Massey test site is rapidly evolving from a quiet outpost into a key hub for Starship development. After a brief shutdown, it's back stronger than ever, with new tanks, reinforced structures, and advanced test stands driving faster, safer, and more efficient progress. Now central to SpaceX's rapid testing push, Massey is accelerating Starship toward full operational readiness. Within SpaceX's vast network of facilities, the Massey test site has long been overlooked. But over the past year, it has rapidly risen in importance, transforming from a quiet support area into one of the key testing centers for the Starship program. Once a modest complex tucked away near Starbase, Massey is now the forefront of SpaceX's most critical ground system upgrades. The shift began when SpaceX designated Massey as a primary test site for Starship. This change led to the construction of a new flame trench designed to handle the tremendous forces and heat from Starship's Raptor engines. Yet the true turning point came earlier this year when a devastating explosion involving the S-36 vehicle caused widespread damage across the site. For a moment, it seemed Massey's role would fade into history. Instead, that disaster sparked a remarkable rebirth. During the 6 months that followed, while testing temporarily moved to Pad 1, Massey underwent one of the most extensive upgrades in its history. At the heart of this transformation is the brand new QD system, which supports fueling and other vital connections between Starship and ground systems during testing. After the S-36 accident, the previous QD hardware was found completely destroyed, forcing SpaceX to start over. The new version is designed specifically for Starship V3, featuring updated interfaces and reinforced structures. Recent images show the ship QD system being assembled on-site, still mounted on scaffolding as crews install protective shielding and route new hiring and piping. The visible panel includes two distinct connection points that align with Starship's updated fueling ports, designed for faster and safer propellant transfer. While SpaceX has not revealed every detail, it's expected that the new QD will include higher capacity pumps and improved sealing systems, cutting fueling time while boosting overall reliability. With Starship V3 prototype S39 nearing completion by the end of this month, the new ship QD is expected to be ready in time for early December testing. Because Flight 12 has been delayed to January, both the vehicle and the Massey site will have a comfortable window for final checks. Testing will begin with cryogenic proof trials, which will validate the new fueling system under extreme cold, followed by a static fire test late in December if everything proceeds smoothly. Alongside this, SpaceX has also been working on the BQD. First spotted in August, this new assembly is installed on the gantry structure that supports propellant lines and mechanical connections for booster tests. Compared to the Pad 1 design, this updated BQD features a reconfigured interface and thicker pipe routing to match the evolved Booster V3 design. Judging by construction progress, the BQD appears fully operational and ready for use. The next booster in line, B-18, is also nearly complete, with its final parts arriving at the Mega Bay earlier this month. According to SpaceX VP Kiko Donchev, B-18 will undergo its cryogenic test in mid-November, followed by a static fire at Pad 2 in early December. Beyond these headline upgrades, Massey's test stands and support systems are also being rebuilt. Which was damaged during the S-36 explosion is being reconstructed with a similar four-legged platform designed for stability, though internal components like the clamp and hold-down systems are being re-engineered to fit the new V3 engines. The fuel lines across the site are also being replaced with larger, more durable pipes paired with stronger pumps to improve fueling speed and pressure management. The S-36 disaster, though costly, has led to an even stronger and more capable testing facility. Each repaired pipe and newly welded beam tells a story of resilience and innovation, turning a site once defined by destruction into a platform for progress. Its rebuilt infrastructure will help SpaceX test engines, verify cryogenic systems, and push the limits of what the world's most powerful rocket can achieve. In the end, the rebirth of Massey is more than just an engineering milestone. It's a symbol of SpaceX's ability to adapt, rebuild, and push forward no matter the obstacle. With every new test and every new vehicle, the lessons learned at Massey will help shape the future of Starship and ultimately the path to making life multiplanetary. So as the next chapter of Starship testing begins, one question remains. Which of these upgrades excites you the most? Share your thoughts in the comment section down below, and let's continue exploring the remarkable comeback of SpaceX's reborn test site. Beyond upgrades, the future of SpaceX's Massey test site depends heavily on one critical factor: expansion. Unlike the larger and more flexible areas at Starbase, Massey occupies a relatively small, finger-shaped stretch of land surrounded by a shallow moat. The site originally served as an old shooting range before SpaceX acquired it, which gives it a unique shape but also limits how much infrastructure can be added within its current boundaries. Because of this limitation, any meaningful expansion will likely require SpaceX to acquire additional land in the surrounding region. The main challenge in doing so will come from environmental regulatory agencies, which oversee development across the wetlands surrounding Starbase. However, SpaceX has strong backing from the Texas state government and long-term plans for what Elon Musk has called Starbase City, which is a fully developed aerospace hub that could include expanded testing and operational areas. If that vision moves forward, the Massey expansion could fit neatly within those broader ambitions. So what benefits would expansion actually bring? Most importantly, it would dramatically increase Starship's testing frequency. At the moment, Massey can handle its current workload comfortably, but that will not last. Within the next 6 to 12 months, as SpaceX ramps up production and prepares for a new cadence of flights, the demand on the test site will rise sharply. Future flight schedules could include up to 25 Starship launches from Starbase per year, each requiring a rigorous sequence of pre-flight tests. Many of these missions will test critical technologies such as orbital refilling, payload deployment, and two-stage landings. To maintain this pace, SpaceX must produce, test, and launch multiple prototypes simultaneously. That means the pressure on test infrastructure will only continue to grow. The production side of Starbase is already evolving to meet the challenge. SpaceX is pushing the Star Factory into full-scale production mode, and the construction of large facilities such as Gigabay and new stacking bays will allow several Starships and Super Heavy boosters to be assembled at once. This rapid production rate will require a corresponding increase in testing capacity, especially at Massey, which plays a crucial role in early-stage validation. It also It's also important to remember that Starship development extends beyond Texas. SpaceX has already established 2 Starship launch complexes in Florida, with at least 3 more in the planning stages. However, those sites currently lack full testing infrastructure. Until those facilities are complete, the Massey test site will remain the primary testing ground for prototypes bound for both Texas and Florida. At present, Massey has just 1 booster test stand and 1 ship test stand, which is far from sufficient to handle the volume of future vehicles. To sustain parallel testing operations and ensure that one platform's activities do not interfere with another, additional stands will be essential. That can only happen through physical expansion, which will give SpaceX the room it needs to build more robust, safer, and faster test systems. No matter what changes come to Massey's test site or to SpaceX's Starship testing system overall, one key foundation remains essential: the flame trench. This feature has become a defining component of the company's testing infrastructure, serving as both a safeguard and a performance enhancer for the world's most powerful rocket. The flame trench works through a simple yet brilliant design. Beneath the test stand lies a deep pit that channels exhaust gases through an angled tunnel, directing them away from the rocket and the stand. Lining this tunnel is a series of pipes that minimize damage from the blast. This setup allows the immense power of the Raptor engines to be safely dispersed outward instead of directly downward, protecting both the infrastructure and the vehicle. The benefits were immediate. The flame trench at Massey made tests far more reliable, allowing SpaceX to conduct repeated static fires without severe damage to the pad or surrounding systems. Even after the mid-year S-36 explosion, which severely damaged parts of the test site, the flame trench itself remained intact. That event was traced back to a vehicle malfunction, not a system failure, proving how resilient and effective the trench design truly is. Because of this success, SpaceX decided to expand the flame trench concept beyond Massey. The lessons learned there inspired its application to the major Starship launch complexes, starting with Launch Pad 2 at Starbase. The system proved so effective that SpaceX replicated and improved it for other sites, including LC-39A in Florida and the soon-to-be upgraded Pad 1 at Starbase. Future Starship pads are also expected to follow the same design principle. SpaceX has confirmed refining the system, even introducing dual flame buckets on some pads to distribute thrust more evenly. This is especially important for the 33-engine Super Heavy booster, whose collective power generates over 7,600 tons of thrust, which is already the most powerful rocket stage in the world. But SpaceX's ambitions do not stop there. The next generation of Raptor engines aims to push that figure past 10,000 tons of liftoff thrust, meaning that durable and optimized flame trenches are absolutely essential for long-term operations. It's not an exaggeration to say that the Massey test site has become a pioneer for innovation within SpaceX's broader testing network. The story of Massey is far from over. The site is still expanding and evolving. More upgrades are already planned, and each one will bring the facility closer to matching the scale of SpaceX's ambitious launch schedule. From a quiet, seldom mentioned area to a centerpiece of SpaceX's testing program, the Massey test site has indeed risen from the ashes. Its rebirth after adversity stands as a symbol of the company's relentless drive to improve, adapt, and push boundaries. As the site continues to evolve, one thing remains certain: the flame trench that helped define its success will continue to burn bright at the heart of SpaceX's journey to the stars. Confusion now defines China's aerospace efforts, as recent setbacks have raised serious concerns, and the responses to them have only deepened the uncertainty. These events serve not just a warning for China, but as a reminder to the global space industry that critical issues and emergency systems must be addressed without hesitation. So how should the world confront these challenges, and what role might SpaceX play in shaping the solutions? In everyday life, even a small incident can create consequences far larger than anyone expects. The same idea has proven true for China's aerospace program in recent days. A tiny piece of space debris struck the Shenzhou 20 spacecraft and created a serious problem that disrupted the entire schedule of China's crewed space operations. What began as a minor impact quickly turned into a major concern for the safety of astronauts living on the Tiangong space station. Thankfully, according to the most recent update, the situation did not end in disaster. At 3:45 a.m. Eastern on the 14th of November, which was 1 full week later than originally planned, the Shenzhou 20 crew landed safely at the Dongfang landing site in Inner Mongolia. Their return marked the end of a mission that lasted more than 6 months on China's space station. The landing sequence went smoothly, and early reports confirmed that the astronauts were in good physical condition and high spirits after coming home. However, this does not mean China's problem has been solved. In fact, the core issue became even more complicated. The Shenzhou 20 crew did not return on their own spacecraft. Instead, they used the Shenzhou 21 spacecraft as their ride home. This was one of the options that had been discussed previously. The benefit of this approach was clear. It allowed China to avoid relying on external assistance, helped return the Shenzhou 20 astronauts earlier, and reduced pressure on food supplies aboard Tiangong. But there is also a much bigger downside. By using the Shenzhou 21 as the return vehicle, the risk shifted entirely to the Shenzhou 21 crew. They are still in orbit, and they now occupy a spacecraft with documented damage. Essentially, the Shenzhou 21 astronauts are stranded until a new spacecraft arrives. If any complications arises before that happens, they will have no escape option. Situations like this should never occur during a crewed mission because the margin for error in space is extremely small. The concern grew even more serious when official updates from China were released. According to Xinhua News, citing information from the China Manned Space Agency, the Shenzhou 20 spacecraft does not meet the requirements for the astronauts' safe return and will remain in orbit to continue relevant experiments. Xinhua also noted that tiny cracks have been found in the return capsule's viewport window, most likely caused by external impacts from space debris. A crack like this presents a major risk. Even a small fracture can weaken the integrity of the return capsule. During re-entry, the spacecraft experiences intense vibration, rapid heating, and extreme pressure changes. A fracture that appears stable in orbit could easily expand during this violent descent, potentially causing a loss of pressure inside the cabin. A failure of this kind would threaten the lives of the crew. This is why the Shenzhou 21 astronauts are now facing a dangerous situation. Although it is unlikely that Tiangong will experience an emergency severe enough to force an evacuation, the fact remains that they currently have no functional spacecraft to escape in. Space is unforgiving, and even if the probability of an emergency is low, every crew must always have a safe and ready return vehicle. In addition to their normal mission tasks, the Shenzhou 21 crew must also examine the damaged Shenzhou 20 spacecraft. If they can understand the problem and safely resolve it, that would be an ideal outcome. If the issue cannot be fixed, their responsibility will shift to preparing Shenzhou 20 for an uncrewed return to Earth once a replacement vehicle arrives. This situation is similar to NASA's handling of the Starliner capsule when it was sent back without astronauts. Because repairing Shenzhou 20 in orbit is unlikely, attention has now turned to the next spacecraft in line. A separate report indicated that China may soon launch Shenzhou 22 uncrewed and packed with food and supplies to support the current mission. However, the report did not give a timeline, only stating that it would launch at an appropriate time in the future. With such vague guidance, the astronauts aboard the Tiangong are likely unsure of how long they will need to wait. Fortunately, other sources have provided slightly more hopeful information. They suggest that China is preparing a Long March 2F rocket and a Shenzhou spacecraft, most likely Shenzhou 22, to a state of near readiness. If a new problem arises on Tiangong, the spacecraft could reach the station in roughly 8.5 days. While that timeline is still risky, it is far safer than having no available option at all. Given how urgent the situation appears, it is possible that China has already begun launch preparations and may send a rescue vehicle within days. So, putting competition and national rivalry aside, the question is straightforward. Should China immediately launch a new spacecraft to ensure the safety of the Shenzhou 21 crew? If you agree, let me know in the comments with a "let's do it now." Looking closely, China's current situation bears a striking resemblance to last year's Starliner incident, though in many respects it is even more serious. In both cases, astronauts were unable to return home on schedule due to significant spacecraft issues, forcing extended delays in orbit and creating cascading impacts across multiple missions and timelines. However, the causes behind the two events are very different. Starliner's problems stemmed from internal technical failures, including malfunctioning thrusters and a persistent helium leak. These issues forced Butch Wilmore and Suni Williams to remain on the ISS for 9 months instead of the 10 days originally planned. By contrast, the Shenzhou crews encountered trouble due to an unpredictable external factor, a small piece of space debris that damaged the return capsule. This was not a design flaw or a system malfunction, but an unavoidable hazard of operating in low Earth orbit. Yet, when comparing the two incidents, the Shenzhou 20 case carries heavier consequences. While NASA had the option of using SpaceX's Crew Dragon as a backup to bring the Starliner astronauts home, China has no such external support. Their astronauts can only wait for another Shenzhou spacecraft to arrive, and the timing of that arrival depends entirely on China's own launch readiness. Even if China allowed foreign assistance, docking another nation's spacecraft with Tiangong is highly impractical because of fundamental hardware, software, and standards incompatibilities. This challenge exists largely because China has chosen to operate its human spaceflight program in a highly closed manner, limiting collaboration and reducing potential rescue pathways. Had the system been more interoperable, the Shenzhou 21 crew could have far more options and far less uncertainty. Ultimately, these events reveal a growing truth. Problems in crewed spaceflight are becoming a more frequent, not less, occurrence. They can emerge without warning from inside a spacecraft or from the environment around it, and they can happen to any nation at any time. So the critical question becomes clear: how do we prepare for the next incident before it happens? With that said, we now recognize a turning point for the global space community. The recent challenges, including China's Shenzhou situation, have shown that no nation can shoulder the risks of crewed spaceflight on its own. A unified support framework is becoming essential, and SpaceX is uniquely positioned to take a leading role in shaping that new era of cooperation. The first pillar of that framework should be an international space rescue system. Every agency or company with launch capability would contribute vehicles, infrastructure, and mission support. When an emergency occurs, the network would activate immediately, sending either a crew vehicle to retrieve astronauts or a cargo craft to deliver supplies. It would operate like an orbital emergency service. SpaceX's Dragon stands at the center of this idea. It's the world's most reliable crew spacecraft, with dozens of successful missions and a flawless human flight record. NASA routinely depends on Dragon for transport and logistics, and SpaceX maintains multiple flight-ready vehicles, each capable of more missions than originally certified. When Starliner encountered issues last year, NASA relied on Dragon once again, reserving seats on Crew 9 for Butch and Suni. That event demonstrated exactly how a permanent rescue system should function. A global framework would not rely solely on Dragon. Other agencies would contribute their own spacecraft, launch capacity, and mission control assets. The goal is cooperation, not centralization. The second pillar should be a unified hazard tracking network to monitor debris, abandoned satellites, and potential impact threats. With launch activity increasing every year, real-time awareness is now critical for safety. Starlink could serve as the backbone of this system, using thousands of satellites to relay data instantly and support predictive alerts. Combined with sensors from around the world, this network could dramatically reduce orbital risks. The third pillar should focus on active debris removal. Starship, with its immense size and payload capacity, is uniquely suited to this task. For years, the idea of using a large vehicle to capture or deorbit debris has been limited by technology. Starship changes what is possible, making large-scale cleanup both practical and urgent. The recent Shenzhou 20 incident shows why such a capability can no longer be delayed. Technically, building these systems is within reach. The real challenge is organizational. Nations and companies must be willing to share data, open their architecture, and collaborate. Much of that depends on China's willingness to participate, as its closed systems remains a barrier to global coordination. Even so, the benefits of a unified safety framework are undeniable. These systems would protect astronauts, preserve spacecraft, and strengthen long-term access to orbit for all. What other systems do you think the world should build together? Share your ideas in the comment section down below. We are indeed entering an era in which the challenges of spaceflight are accelerating faster than our ability to keep pace. The farther crews travel and the longer they remain in orbit or beyond, the more chances there are for unforeseen issues to arise. Recent events, from China's stalled Shenzhou mission to Starliner's prolonged delay last year, have made it clear just how quickly even the most carefully planned operations can be thrown off course. The global space community must now take decisive steps to confront these risks before they grow beyond control. Cooperation will not be simple, especially in an era of intense competition, but safety has to rise above national and commercial rivalry. Without collective action, the dangers will only worsen. In this effort, SpaceX is positioned to lead once again. The company's track record of achieving breakthroughs once seen as impossible, combined with its operational experience and active fleet, gives it a strong foundation to help shape a shared emergency support system for space. If such a system is built, human spaceflight will become far more resilient and secure. The question now is whether SpaceX and other organizations can act quickly enough to make this vision real, and what form this new era of cooperation will ultimately take. Wow! Witness SpaceX's upgraded OLM, a bold step toward the future of the Starship program. First seen at Starbase and now rising in Florida, this new installation marks a major stride in expanding SpaceX's launch network. More than hardware, it embodies SpaceX's drive for speed, reliability, and rapid reuse. Key elements that will redefine modern spaceflight. So how will this upgrade propel the Starship program forward? It can be said with confidence that alongside Starbase in Texas, Florida is quickly rising as the second great center of Starship operations. A rocket as monumental as Starship could never be absent from Florida, the historic heart of America's space industry, and the place where so many legendary missions have taken flight. In terms of progress, Florida's facility often trails behind Starbase, yet that does not diminish its importance. While Starbase remains the birthplace and primary testing ground of Starship, the Florida site represents its expansion into a more mature operational phase. It's worth noting that the LC-39A and SLC-37 areas in Florida have been proposed for as many as 44 and 76 missions per year, respectively, compared to only about 25 at Starbase. This makes it clear why accelerating development at Florida's launch pads has become a priority. Among these, Launch Complex 39A stands as the true pioneer. This historic pad, which once launched Apollo and Falcon Heavy missions, is now being transformed into a cornerstone of the Starship era. It already features a towering launch structure equipped with the iconic chopsticks arms used to lift and eventually catch the rocket. Its OLM had been constructed earlier, but in early 2024, the original legs were demolished so that the pad could adopt the improved design used at Starbase's Pad 2. Recently, the upgraded OLM was rolled out from Roberts Road to the launch site, marking a significant milestone. The new structure closely mirrors the design of the OLM at Starbase, featuring a robust box-shaped frame with large manifolds encircling it. Installation began immediately after its arrival. The OLM was positioned onto the raised platform that had been carefully prepared, and welding work commenced to secure it in place. This milestone is crucial because the OLM serves as the foundation of all Starship operations at the pad. Earlier in the year, SpaceX had already completed the digging of the flame trench to provide a solid base for the launch structure. By October, the massive flame buckets that will channel the fiery exhaust from the engines had begun to be placed within the trench. trench. The speed of construction at LC-39A has been impressive, only slightly behind that of Starbase's Pad 2. If this pace continues, the pad could very well be ready for operation by mid-2026 or perhaps even earlier. Still, there remains a great deal of work ahead. SpaceX must now focus on completing several crucial systems around the pad. Next to the flame trench, the company will construct the gantry system for the quick disconnect booster arm, which will supply fuel and power to the rocket before liftoff. Additionally, pipelines are being installed to connect the water and fuel storage areas to the flame bucket and OLM. Once these systems are integrated, protective covers and shield structures will be added to ensure safety and stability across the pad. At the top of the launch tower, the chopsticks system will undergo further adjustments. These include modifications to their length and the installation of new lifting and catching mechanisms designed specifically for the upgraded V3 Starship. After construction is complete, the pad will enter a rigorous testing phase. This will begin with venting and water deluge tests, verifying the pad's ability to handle heat and pressure during launches. Then comes the most anticipated milestone, the static fire test. This will mark the first time the new pad supports a booster prototype generating more than 9,000 tons of thrust. Once that test succeeds, the pad will officially be ready for full Starship operations. Based on current progress, SpaceX could finish major construction by March of next year, with testing expected to begin around April or May. This timeline aligns perfectly with SpaceX's plan to transition to the new Starship V3. Over the next several months, SpaceX will test V3 upgrades, demonstrate orbital operations, perform stage catch attempts, and deploy payloads. Once those objectives are complete, the company will begin building out its orbital refilling infrastructure. This is where LC-39A will play a crucial role. Beyond supporting NASA's Artemis-related missions, including Starship HLS, the Florida site will likely serve as a key hub for Starship's refilling operations. While these missions will not begin immediately once the pad becomes operational, several test flights will pave the way for that next phase. If construction continues smoothly, we could see at least 2 major Starship launches from LC-39A next year, with refilling tests to follow soon after. In summary, SpaceX is making a major push with LC-39A. Thanks to the existing infrastructure and lessons learned from Starbase, progress has been remarkably swift. Many once believed that this pad would not be ready until 2027, yet the rapid installation of the upgraded OLM and other components now suggests otherwise. If everything goes as planned, Florida could witness its first Starship liftoff much sooner than expected, marking the beginning of a new chapter in the program's expansion. So, are you ready to see Starship rise from Florida's coast next year? Comment, "Let's go Starship Florida," and don't forget to like the video and subscribe to our channel to stay up to date on SpaceX's incredible journey to the moon and beyond. Excitement is building, but it's important to remember that SpaceX still has a tremendous amount of work ahead before the Florida Starship system becomes fully operational. In the previous section, we discussed the construction progress and schedule of the new launch pad, but a functioning launch site requires much more than just the pad. To operate efficiently, SpaceX must also complete the production, testing, and fuel supply systems that will support continuous Starship launches from Florida. These essential systems are not expected to be fully ready until late 2026 or perhaps even 2027. During this early stage, SpaceX will likely rely on Starbase in Texas to produce and transport rockets by sea to Florida. This method of maritime transport has already been tested successfully, and it'll serve as a temporary bridge between the two sites while Florida's infrastructure catches up. In the meantime, SpaceX will be working intensely to build out every remaining element of the Starship system in Florida. One of the most important upcoming facilities is the new Gigabay. This massive structure has already been clearly outlined in SpaceX's plans and will be constructed near the Roberts Road complex. Based on the proposed dimensions, the Gigabay will be capable of supporting stacking, testing, and refurbishment of multiple Starship and Super Heavy booster prototypes at once. Its scale and efficiency will make it a vital component in ensuring that Florida can eventually operate as independently as Starbase. However, the true heart of Starship operations in Florida will be the upcoming manufacturing facility, often referred to as Star Factory Florida. Although it has been mentioned in planning documents and public discussions, detailed updates on its approval or construction timeline remain limited. It's likely that this facility will take shape once the ongoing expansion of the Roberts Road area is complete. Once operational, Star Factory Florida will greatly accelerate Starship production thanks to its use of advanced manufacturing techniques such as high-precision welding and large-scale 3D printing. The facility will likely be organized with streamlined production lines to allow for simultaneous work on multiple vehicles in various stages of completion. This step will not only ensure a steady flow of prototypes for both LC-39A and later SLC-37, but it'll also significantly reduce SpaceX's reliance on transporting hardware from Starbase. The testing infrastructure will also play a crucial role in Florida's long-term operations, though little has been revealed about it so far. SpaceX will almost certainly need additional test stands near Roberts Road or possibly near one of the launch pads themselves. These testing areas would likely adopt a design similar to the flame trench system already in use at Starbase's Massey test site, allowing for static fire tests and structural checks before vehicles head to the main launch pad. Finally, the Florida site will need its own dedicated fuel production and storage plant to support frequent Starship launches. Fortunately, compared to the remote and environmentally sensitive surroundings of Starbase, building a fuel plant in Florida will likely be less complicated. The proximity to existing industrial zones and transportation networks could make fuel distribution more efficient and reliable for long-term operations. Taken together, these systems represent the next great phase of SpaceX's expansion. Florida is not just an alternative site, it's the foundation for a dual launch capability that will eventually allow SpaceX to conduct Starship together. From the Gigabay and Star Factory Florida to the test stands and fuel plant, the state will become a true powerhouse for the company's lunar and deep space ambitions. With SpaceX's rapid progress in Florida, it's becoming increasingly clear that the company's long-term ambitions and operational scale are set to outpace every other competitor in the aerospace industry. What we are witnessing now is not just an expansion of infrastructure, but the foundation of a new launch era, one built to sustain hundreds and eventually thousands of missions across Earth and beyond. At present, SpaceX stands alone in its class. When we count all the platforms under development or in operation, the company now possesses 3 dedicated launch pads for Starship, a figure unmatched by any other organization in the world. These pads form the backbone of a global system designed to make Starship not only the most capable rocket in history, but also the most frequently flown. To put that into perspective, this mirrors the structure SpaceX already achieved with its Falcon rocket family. The company currently operates 3 launch pads for Falcon vehicles, which are LC-39A and SLC-40 at Cape Canaveral in Florida, along with the SLC-4E at Vandenberg Space Force Base in California. With this trio of sites, SpaceX has achieved record-breaking launch frequencies year after year. In fact, these pads have allowed the company to conduct multiple missions within a single day, sometimes mere hours apart. SpaceX's unmatched launch cadence is powered by its advanced recovery systems, which involve including land-based landing zones and autonomous drone ships stationed in the Atlantic and Pacific. These assets have made Falcon 9 the world's first rocket to fly, land, and relaunch repeatedly, driving down costs and achieving a tempo no competitor has matched. Now, SpaceX is scaling this model with Starship. With Starship, 3 dedicated launch pads are already operational, with 2 more proposed for SLC-37 in Florida and potential expansions at Starbase, Texas. Once complete, up to 5 Starship pads could support simultaneous launches, rapid reusability, and continuous operations. Central to this vision is Mechazilla, the groundbreaking launch tower designed to catch and relaunch boosters and ships directly from the pad. This system eliminates lengthy refurbishments, enabling turnaround times for far faster than Falcon 9's. Combined with occasional drone ship recoveries, it sets the stage for near-daily Starship flights. Unlike Falcon 9's partial reusability, Starship is fully reusable, designed to make routine missions to the Moon, Mars, and beyond both practical and affordable. As competitors like Blue Origin, ULA, Rocket Lab, and Stoke Space race to catch up, SpaceX is already operating at industrial scale. From Starbase to LC-39A, every expansion signals the dawn of a new era. one defined by speed, innovation, and a bold vision for humanity's future in space. Blue Origin has scored a major win with its second orbital flight, successfully delivering its payload and nailing the booster landing. It's a milestone that could shift industry momentum in meaningful ways. Firefly has also disclosed the root cause of its recent booster test failure, outlining a clear path forward. And in China, challenges continue as another commercial rocket mission has ended in failure. The second mission of New Glenn has become the central focus of the launch community, a mission that kept audiences waiting for 10 months after its debut flight. After a long series of delays, the rocket finally lifted off at 3:45 p.m. Eastern on November 13th from SLC-36 at Cape Canaveral, the dedicated Blue Origin pad restored specifically for this new generation of heavy lift missions. Riding uphill with two NASA Escapade spacecraft on board, New Glenn began a flight that would carry enormous expectations, intense scrutiny, and the weight of Blue Origin's future ambitions. Despite a terminal count abort earlier in the attempt, the mission proceeded with remarkable steadiness once the clock resumed. Propellant loading, avionics checks, and payload verification were all executed cleanly. When the engines ignited, the combined forces of 7 BE-4 engines, producing a total of 1,750 tons of thrust, carried the vehicle skyward. From liftoff onward, the sequence of mission milestones unfolded with impressive precision. New Glenn passed through the period of maximum aerodynamic pressure, completed stage separation, initiated the second stage burn, guided the booster through atmospheric descent, reignited the engines in space, and deployed the payload. Each update from Blue Origin, Jeff Bezos, and Dave Limp confirmed the vehicle's health, and the steady stream of posts on X underscored how significant this flight was to the company. Two achievements defined this mission above all the others: the deployment of the payload and the successful landing of the booster on the drone ship Jacqueline. These accomplishments were proudly stated in Blue Origin's summary. New Glenn had delivered NASA's twin Escapade spacecraft, powered on and transmitted data from Viasat's HaloNet technology demonstration, and returned its first stage intact on the autonomous landing vessel. These milestones were more than simple checkmarks. They represented meaningful progress toward the company's goals of reliability, reusability, and commercial competitiveness. The payload deployment stood out as a major accomplishment, especially because it differed from the inaugural mission. This time, Blue Origin carried a true operational payload, and not just any payload, but a pair of spacecraft belonging to NASA's Mars exploration program. Performing well on a mission of that significance is vital for Blue Origin's long-term relationship with NASA. Successful delivery builds trust, and trust leads to future missions. It also moves Blue Origin closer to earning launch certification from the U.S. military and other government agencies, something that requires a proven track record of precision and consistency. The mission, however, did not unfold without concerns. Before liftoff, NG-2 had experienced two delays, one of which was caused by a powerful aurora visible across large parts of the world on November 11th. That aurora was a symptom of an intense solar storm fueled by a surge of charged particles leaving the sun, an event known as a coronal mass ejection, or CME for short. These storms can pose serious risks to spacecraft electronics by disrupting circuits, damaging microchips, and interfering with communications. The storm that triggered the earlier delay reached speeds of up to 500 kilometers per second, making it one of the strongest observed recently. Many wondered whether New Glenn's second mission would be postponed again to protect the Mars-bound spacecraft. The concern was justified because Escapade will spend a long period beyond Earth's protective atmosphere and must function flawlessly throughout its deep space journey. Ultimately, engineers determined that the storm no longer posed a threat to ground systems or the rocket at launch. Even so, once the spacecraft left Earth's shielding, it would still be exposed to solar radiation. For that reason, continued monitoring of Escapade remains essential as it begins its long trek to the Red Planet. Though the deployment was successful, its mission has only just begun, and every step of its cruise phase will carry immense scientific importance. Turning back to New Glenn itself, the booster landing marked an equally important triumph. Unlike the payload deployment, the landing was visible and dramatic, broadcast live for the world to see. The previous mission had seen the booster fail to land, making this attempt especially meaningful. Viewers watched as the booster used its aerodynamic fins to maintain stability through atmospheric descent. Moments later, all three BE-4 engines ignited to guide and slow the vehicle. The sequence revealed how carefully the Blue Origin team studied and resolved the earlier issue. As the booster approached the drone ship, the landing legs deployed cleanly, the engines throttled precisely, and the rocket touched down without incident. Shortly after, Blue Origin confirmed that Jacqueline was already en route to return the booster to port. This milestone officially signals New Glen's entry into the modern competition for rapid reuse. Blue Origin accomplished a successful drone ship landing on only its second flight. By comparison, SpaceX required nearly 6 years and 23 missions to perfect landing on an autonomous vessel. While it is true that SpaceX paved the way, allowing Blue Origin to benefit from a decade of industry-wide learning, the achievement remains significant. Blue Origin spent 25 years preparing for this moment, and the successful recovery reveals clear engineering skill and determination within its team. Full reusability will shape the future of launch services by reducing costs and increasing launch cadence, and New Glenn now stands among the growing family of rockets capable of achieving it. The broader impact of this mission extends beyond a single company. The success strengthens Blue Origin's role as a major competitor in the U.S. launch industry. It positions them to challenge SpaceX and ULA and prepares them for future competition with younger companies such as Stoke Space and Rocket Lab. Internationally, New Glenn's progress reinforces American presence in spaceflight as global competition intensifies, especially with China's expanding ambitions and recent launch setbacks. The reaction across the aerospace community was immediate. Elon Musk shared 2 congratulatory messages with Jeff Bezos and the Blue Origin team. Gwynne Shotwell, the president of SpaceX, praised the landing as magnificent. NASA Acting Administrator Sean Duffy emphasized the importance of the launch in maintaining American leadership in space exploration. Jared Isaacman, a leading candidate to become the next NASA administrator, celebrated the excitement of the mission and congratulated the teams responsible for the Escapade launch and the safe booster recovery. With this mission, Blue Origin has demonstrated real progress and gained credibility in ways that will shape its future. Now the question turns to the public. Has Blue Origin earned a place as a serious competitor to SpaceX? Please respond with a yes or a no in the comment section down below. Now, let us move on to the latest updates from Firefly Aerospace. After a month and a half ago, in late September, Firefly conducted a booster test in preparation for its 7th Alpha mission. During that test, the booster unexpectedly exploded. In Firefly's most recent update, the company clarified that although the vehicle was destroyed, the test stand and all surrounding systems remained unharmed. That detail is important because it shows that the protective structures performed exactly as designed. In the same statement, Firefly officially announced the cause of the incident. The company wrote, following a thorough review of the Alpha Flight 7 first stage ground test on September 29th, Firefly identified a process error during Stage 1 integration that resulted in a minute of hydrocarbon contamination, which then led to a combustion event in one of the engines during the ground test. The test stand structure remained intact, and no other facilities were impacted. Jordi Paredes Garcia, the chief engineer at Firefly Aerospace, explained the situation in more detail. He stated, "This incident was not caused by a design issue, but rather a process error during a routine integration. As launch providers, our industry recognizes the impact even the smallest errors can have, and that is why at Firefly we rigorously test before we fly." Hydrocarbon contamination is not unheard of in the rocket world. However, it is often overlooked because it can be difficult to detect and easy to underestimate. Even small amounts can interfere with engine behavior, fuel flow, or ignition conditions, which can lead to serious failures during a test or flight. To address the issue, Firefly implemented a series of corrective actions immediately. The company stated Firefly immediately took action and implemented corrective actions, which included increasing inspection requirements for the fluid systems, optimizing the first stage sensors, and incorporating additional automated aborts. Firefly also implemented key process improvements following a day-long quality stand-down, where the production, integration, and test teams conducted exercises to review and optimize existing procedures. Firefly also expressed strong confidence in its future progress. Adam Oakes, vice president of launch at Firefly Aerospace, said, "Naturally, moments like these create opportunities to enhance Firefly's culture and focus on the fundamentals that are required to navigate the complexities of rocket systems." His comment reinforces the idea that setbacks can lead to stronger systems and more reliable missions if a company responds correctly. As for specific plans, the company wrote on X that as the path forward, we're using another Alpha first stage from our production line to support the mission. with a launch targeted between late Q4 and early Q1, depending on range availability. The company also said in the update that it is using another Alpha booster from the production line to support Flight 7, while the second stage has arrived at Firefly's SLC-2 at Vandenberg Space Force Base. Firefly's SLC-2 at Vandenberg Space Force Base. And with that, we arrive at the final chapter of today's developments, China's recent launch failure. At 11:02 p.m. Eastern on Sunday, November 9th, Galactic Energy conducted the launch of its Ceres-1 solid-fuel rocket from the Jiuquan Satellite Launch Center in northwest China. The rocket was carrying 3 satellites into low Earth orbit. According to reports, the first 3 stages performed normally, but the 4th stage shut down prematurely, which resulted in the loss of all 3 payloads. Those payloads included 2 satellites for China's Jilin-1 commercial Earth observation constellation, along with a satellite developed by Zhongbei University. After the failure, an affiliate of the People's Daily reported that the Beijing-based company apologized, saying, "We offer our sincerest apologies to the mission's customers and to everyone who supports Galactic Energy." The company also stated, "We will learn lessons from the mission setback and continue to optimize rocket design and quality management systems." This is the second launch failure for the Ceres-1 rocket. The vehicle debuted in November of 2020 and has now flown a total of 22 times. In addition to this most recent loss, it also encountered a failure in September of 2023. Despite these issues, Galactic Energy plans to return the rocket to flight as soon as possible. The company is also working on 2 next-generation vehicles, Ceres-2 and Pallas-1, both of which are designed with reusable booster features similar to the Falcon 9. Of course, matching the Falcon 9's performance is an extremely difficult goal for any company. Still, it'll be interesting to see how much progress Galactic Energy can make as they refine their technologies and respond to these setbacks. In any case, this has been Kevin with Great SpaceX. Don't forget to like the video and subscribe if you haven't already to stay up to date with yours truly on the latest milestones in SpaceX's journey. Thank you so much for watching, and always remember, curiosity, imagination, and inspiration will follow you so long as you keep looking up.